Welcome back to the second stream today, as we have to finish some challenges for the Azure, the Build Cloud Skill Challenge. And we just finished one of the Devops challenges, and we are now over to another one. Run quality testing your build pipeline using Azure Pipelines. I'm not sure why my tags are incorrect for Twitch, but let's first start the show. Welcome back. Let's quickly open the code window to continue with our next task. Run quality tests in your build pipeline. And for that we have to open the challenge. It should be on the right window. There we are. What are we going to do? Learn the benefits of automated testing, run unit tests, add dashboard widgets to visually test runs, perform code coverage, and see a test fail in the pipeline and then fix the failure. What do we need? All the things that we needed from the previous one. And a lot of explanations probably. So let's dive in. Introduction. There we have the prerequisites again. Meet the team, we've seen them before, and the development, meet a QA. Tim is operations, he's new. Mara just joined us as developer and reports to Andy. Mara prior experience with DevOps and helping the team to adopt the streamlined process for Azure DevOps. What is automated testing? Automated testing. In this unit you learn all the benefits of automated testing and the kinds of testing that you can perform. Also learn what makes a good test and can be introduced to various testing tools available. Let's begin with checking with the Tailspin web team. Well, we already had them in the team from the previous side. What is UI, your automated testing? Automated testing uses software to execute your code and compare the actual results with the results that you expect. Compare this with exploratory or manual testing, where a human typically follows instructions in a test plan to verify the software. Manual testing has its benefits, but it's as your code base grows in size, testing all features manually where are we? All features manually, including the edge case, can become repetitive, tedious, and error-prone. Automated testing can help eliminate some of this burden and enable manual testers to focus on what they do best, ensure that the users have the positive experience. Test pyramid is what you think automated testing. It's common to separate into layers. Mike Cohn proposes the concept of test pyramid in his book Succeeding with Agile. Although this simplistic version of the Cohn model, the concept illustrates that you focus most on the effort on writing the tests and verify the foundational levels of your software. Call out one in pyramid, the unit testing, such as function, classes, methods. You focus progressively less effort as features are combined, such as the user interface, the UI layer. Call out 2, the pyramid. The idea is that if you can verify that each lower level component works as expected in isolation, tests in the higher level needs only to verify the multiple components work together to get the expected results. All of a sudden I see a new site bar in Stream Manager. I have to look at that later. little bit smaller. When should I write tests? The answer mainly depends on your needs and experience in writing tests. It's never too late to start adding tests for your code you've already written and deployed. It's especially true for features that often break or require the most effort from your test team. When you relate testing to continuous integration and continuous delivery pipelines, the two concepts you will hear about are continuous testing and shifting left. Continuous testing means tests are run early in the development process and every change moves through the pipeline. Shifting left means considering software quality and testing earlier in the development process. As an example, developers are often add test case as they develop their features and run the entire suite of tests before they submit the changes to the pipeline. This approach helps ensure both that the feature they are building behaves as expected and it doesn't break existing features. Here's a short video from Abel Wang, Cloud Advocate. Microsoft explains how to ensure you maintain your quality in the DevOps plan. Let's kill the music for a while and let's see if we can get audio on this one. Yes.
How do you ensure quality in a DevOps world? This is also a great question. With the advent of these CI/CD pipelines, we are now able to really easily check in a change in our code and have that change deployed all the way out into production, right? So the need for quality is even more than ever before because any changes we make get pushed into production super easily, and we don't want to be pushing bugs really, really quickly into production, right? So the key is, how do you ensure quality? Because back in the day, before we had these CI/CD pipelines, the way we ensured quality was by doing end-to-end functional testing, which was great, it worked great, but the problem with that is end-to-end functional testing takes a really long time to do, right? So for a big project, it's easily conceivable that your end-to-end functional test could take 3 months, 4 months, a year, maybe even longer, right? And with our pipelines, nobody has time to do that, right? We want to be able to continuously deliver value. So in order to ensure quality, we need to shift left, put more of the burden of quality onto developers. So what that means is, you know what, we need to write really, really good unit tests. Unit tests that test absolutely everything. This becomes incredibly vital. Now with the unit tests, the power of unit tests is they run extremely fast, and they run during your build. So now you make a change, you add all of your unit tests, you check in your code, and immediately it kicks off the build, runs your unit tests, sees if everything's okay, and if everything passes, then it can go through your release pipeline. The other thing you can do is you can add automated UI tests in your release pipelines as well. So, once again, the key to ensuring quality in the DevOps world is by pushing and shifting left. Burden of responsibility for quality falls more on developers. Write your unit tests. Super important.
Super important. As you can see. Try Azure 2. I wonder what Try Azure 1 means. Shifting left often requires testers to get involved in the design process even before any code for the feature is written. Compare this to the handoff model, where the test team is presented with new features to test only after the software is designed and written. A bug discovered late in the process can affect in the team's delivery schedule, and bugs might be discovered weeks or even months after the developer originally built the feature. Trade-off. With the automated testing, there comes a trade-off. Although automated testing enables the testers to focus their time verifying the end-user experience, developers might need to dedicate more time to writing and maintaining their test code. However, the point of automated testing is to help ensure that testers receive only the highest quality code, code that has been proven to function as expected. Therefore, developers can reclaim some of the time by having to handle fewer bugs and avoiding code rewrites because of an edge case they hadn't originally considered. Added benefits, documentation, and the ability to more easily refactor your code are two added benefits of automated testing. Documentation and manual test plans can serve as a type of documentation as how the software should behave and why the certain features exist. Automated tests can serve the same purpose. Automated test code often uses a human-readable format. The set of the inputs you provide represents values your user might enter. Each associated output specifies the result of your user should expect. In fact, many developers follow the test-driven development, or TDD, method by writing the test code before implementing the new feature. The idea is to write a set of tests, often called specs, that initially fail. Then the developer incrementally writes code to implement the feature until all tests pass. Not only do the specs document the requirements, but the TDD process also helps to ensure that only the necessary amount of code is written to implement the feature. Refactoring, as you have a large code base that you want to refactor to make certain parts run faster. How do you know that your refactoring won't cause parts of your application to break? Automated testing serves as a type of contract. That is, you specify the inputs and the expected results. When you have a set of passing tests, you're better able to experiment and refactor your code. When you make a change, all you need to do is run your tests and verify that they continue to pass. After you've met your refactoring goals, you can submit your change to the build pipeline so that everyone can benefit, but with a lower risk of something breaking. What type of automated testing are there? There are many types of automated testing. Each test serves a separate purpose. For example, you might run security tests to verify that only authorized users can access the piece of the software or one of its features. When we mention continuous integration and build pipeline, we typically refer to development testing. Development testing refers to the test that you can run before you deploy the application to a test or production environment. For example, lint testing, a form of static code analysis, checks your code to determine whether it conforms to your team's style guide. Code that's formatted consistently is usually easier for everyone to read. Let's bring back the music. Apply for you to read. Where was it? And maintain. There. In this module, you work with unit testing and code coverage testing. Unit testing verifies the most fundamental components of your program or library, such as an individual function or method. You specify one or more inputs along with the expected results. The test runner performs each test and checks to see whether the actual expected result match. As an example, let's say you have a function that performs an arithmetic operation that includes division. You might specify a few values that you expect your users to enter along with edge case values such as 0 or -1. If a certain input produces an error or exception, you can verify that the function produces the same error. Code coverage testing computes the percentage of your code that's covered by your unit test. Code coverage testing can include conditional branches in your code to ensure that the function is completely covered. The greater your code coverage percentage, the more confident you can be that you won't later discover a bug in code that wasn't fully tested. You don't need to reach 100% code coverage. In fact, when you start, you're likely to find that you have a low percentage, but that's given a starting point from which you can add the additional tests to cover problematic or frequently used code. Keep unit testing isolated. When you learn about unit testing, you might hear terms such as mocks, stubs, and dependency injection. Recall that a unit test should verify an individual function or a method and not how multiple components interact. But if you have a function that calls a database or a web server, how do you handle that? Not only does the call to external servers break isolation, but it can slow things down. If the database or web server goes down or is otherwise unavailable, the call can also disrupt your test run. By using techniques such as mocking and dependency injection, you can create components that mimic this external functionality. You'll see an example later in the module. Later, you can run integration tests to verify your application works correctly in a real database or web server. What makes a good test? You'll be better to identify a good test as you gain experience writing your own tests and reading tests written by others. Here are some guidelines for getting started. Don't test for the sake of testing. Your test should serve a purpose beyond being a checklist item to cross off. Write tests that verify your critical code works, that your critical code works as intended and doesn't break existing functionality. Keep your tests short. They should be finished quickly as possible, especially those happening during development and build phases when tests are run as each change moves through the pipeline. You don't want them to be a bottleneck. Ensure that your tests are repeatable. Test runs should produce the same results each time, whether they run whether you run them on your computer, co-work computer, or the build pipeline. Keep your tests focused. A common misconception is that tests are meant to cover code written by others. Ordinarily, your tests should cover only your code. For example, a common misconception is that tests are meant to cover code written by others. Ordinarily, your tests should cover only your code. For example, if you're using an open source graphic library in your project, you don't need to test that library. Sure. That's quite logical. Choose the right granularity. For example, if you are performance unit testing, an individual test shouldn't combine test multiple function or method. Test each function separately and later write integration tests that verify the multiple components. What types of testing tools are there? The testing tools depend on the type of application that you build and the type of testing that you want to perform. For example, you can use Selenium to perform UI testing, or many types of web browsers and operating systems. No matter what language your application is written in, there are likely a number of test tools available for you. For example, Java application, you might choose Checkstyle to perform the lint testing and JUnit to perform the unit testing. For Space Game website, which is a .NET Core application written in C#, Mara chooses the NUnit for unit testing because it's popular in .NET community, and she and Andy have prior experience with that. According to the test pyramid, where should you spend your majority of time? Running unit tests on your class methods, running integration tests between your web server and database, running manual tests on your user interface. That must be unit testing. Shifting left means fixing all bugs before adding new features, considering software quality and testing early in the development process, testing and undiscovered bugs in the test or pre-production environment. So this shifting left means considering software quality and testing earlier in the development process. Which of the following demonstrates the best testing practices? Test runs quickly and focus on the most used code paths. Comprehensive suite of unit and integration tests is run during each stage of the build process. No, that's taking too much time. Tests cover both the team application code and all open source library the application uses. No, it was just explained to do only your own code. So it must be run quickly and focus on the most used code paths. And we are logged into the system, and we're now moving, I think, to level 6 maybe with this module. 7. Check your answers. Right. Yeah, here we go. Continue. Set up your Azure DevOps environment. Go to Azure Devops project. Run the template, it's just like we did in the previous one. And now I wonder if we are the same person again. Sign in. There's no indication at all if we are the same person. Only if we see it in here. Project name. Project name such as Space Game Web Tests. Oh, copy. Select organization, select template, that's the one. Run quality tests. And select the fork probably. Yes, I want a fork. Authorize. That's already authorized from the previous one. Now create project. Ready for some coffee. Cheers. Project Space Game Web Tests created, forked, MS Learn. One team created, board column, swim lanes, style updated. Work items created. Navigate to project. Now you have a new project. Set a project visibility, it's public. Move work to doing. Where's the boards? Boards. There we are. We now move create unit tests, I think. Create unit tests into doing. And put my name on it. Good. There we are. At the end of this module, after you've completed the task, you move the thing to done. Set up the project locally. There we go with... Still have this one open, I think. We already forked it, so let's go to our own version. Because that's probably what they do here. Fork it. Clone and download. We already did that. Clone. Let's go to that folder. The data projects. Build school. Oh. 2, I think. Yeah. There you go. Command. The window. Well, already cloned. We already did the remote. Remote is already done. Open in the thingy. Add unit tests to your application. Add unit tests to your application. Andy is going to work with Mara to add unit tests to the automated build that Mara created with Azure Pipelines. Regression bugs are creeping into the code and breaking the leaderboards, filtering functionality. Specifically, the wrong game mode keeps appearing. The following images illustrates Amita's problem. When Amita selects Milky Way, to show only scores that from that game map, she gets results from other game maps such as Andromeda. That's not right. Both Andy and Mara want to catch the error before it reaches Amita, the tester. Unit tests are a great way to automatically test for regression bugs, and he also thinks that adding the unit tests now will give them a head start as they improve the space game web. The application uses the document database to store high scores and player profiles. Right now it uses a local test data. Later they plan to connect the app to the live database. A number of unit test frameworks are available for C#. Mara chooses NUnit because it's popular with the community and she's used it before. Here's the unit test you're working with, along with Mara and Andy. Test cases. Fetch only requested game. Blah, blah, blah. You can filter the leaderboard by any combination of game types and game map. The test queries the leaderboard for high scores and verifies that each test result then matches the provided game map. In NUnit test method, test case provided inline data to use to test that method. Here NUnit calls fetch only requested game region. Unit test method like this. Fetch only game requested game region and then for all items. Notice the call to assert. To the assert that. That's let's see. Here. That method at the end of the test. If I have been reading a little bit further, I would know it would be at the end of this. An assertion is condition or statement that you declare to be true. So it should say scores is all matches with the region. Many unit test frameworks provide verification methods that resemble natural language. These methods help make tests easy to read and help you map the tests to the application requirement. Consider the assertion made in the example. Assert that scores is all matches score game region. You might read this line as assert that the game region of each returned score matches the provided game region. Here's the process to follow. Fetch the branch from, it's all the steps explained in here that we are going to do. So first, let's fetch the branch from Github. Let's put it side by side. Git status. That's not interesting at all. Git fetch upstream unit tests. Git checkout branch unit tests. Upstream unit tests. Format command enables you to get starter code from GitHub, and then you move to the new branch. Optional step. If you see the code, open the Azure Pipelines. Yeah, so code dot. Familiarize with the initial configuration. Well, we already checked that in the previous module, so we don't skip that. Run the test locally. .NET build configuration and release. Where is code window? .NET .NET build configuration release. .NET build configuration Release. .NET Test. Now we run the .NET Test command. Copy. .NET Test configuration release, no build. Totally one test. Let's see. No build flag specifies no build, not to build a project before running it. You don't need to build a project because you just did that. You see all 5 tests pass. 5 tests, 5 passed. Run successful. 1 second. Mine is a little bit longer. This example, the test took about 1 second to run. 5 tests. Although we defined the one test method, fetch only requested game region, that test is run 5 times, once for each game map, as specified in the test case inline data. Run the test the second time. The time provided this time provide a logger option to write the results to a log file. Copy. Paste. So .NET Test and then release, no build, and then logger TRX. You see from the output that the TRX file is created in the test results directory. Test results directory. Control click. TRX file is an XML file that documents the results of the test run. It's a popular format for any unit test because Visio and other tools can help you visualize it. Later you'll see how Azure Pipelines can help you visualize and track your test results as they go through the pipeline. TRX files are not meant to be included in source control. Git ignore file enables you to specify whether temporary or other files you want Git to ignore. The project git ignore file is already set up to ignore the test results directory. Where is the git ignore thingy? There. Test results. This one. As optional step in the Visio, open the document db repository get items async suite.css CS document db repository from the tests folder. There's the tests, I think. Document DB repository, there it is. Examine the test code. Even if you're not interested in building .NET Core applications, you might find the test code useful because it resembles code that you might see in other unit test frameworks. Here is the 5 items. Add test to your pipeline configuration. Here you configure the pipeline to run your unit tests and collect the results. As you go to modify the pipeline like this, copy this and then go to the YAML thing. There it is. Control A, Control V. So it added the run unit tests part. Version introduces .NET Core CLI 2 build task. Run unit test, that's the yellow part in here. The build task runs the .NET test command. Notice that this task does not specify the logger that you used when you run the test manually. The public test results argument adds that for you. This argument tells the pipeline to generate a TRX to a temporary directory accessible through the agent temp directory. It also publishes the task results to the pipeline. The project's argument specify all C# project star CS proj that match the CS proj. Star part matches all directories, and the tests proj part matches all the projects with the name and test projects. Unit test branch contains just one unit test. Tailspin game web tests the C proj. This one. But by specifying pattern, you can run additional test projects without the need to modify your build configuration. Push the branch to GitHub. Let's first save everything. Save this. Close the logging file. Copy. There we go. Azure Pipelines commits it and push. Still has the exception. What's the Azure Pipelines? I think I have the thing is still open somewhere here. There's the game space game. Pipelines. There we are, it's now building. Let's go into this job. Here's the test section. In Azure Pipelines trace the build through each of the steps. You see that the run unit test runs the unit test. Let's wait for that. From gulp. Write build info, restore, build projects. Almost there. There's the unit test. 5 tests, 5 passed. Finalize job. Done. So now this should be green with one published drop. There we have space, web tests, and the web. Navigate back to the pipeline summary. Oh, we now have tests item in there. Tests in here. Move to the tests tab. Log summary. Now the question is, where are the test tabs? Log summary. No. Oops. Oh, let's see. I think I now closed my Devops thingy. Let's reopen. Devops. There it is. So where is the test step? No. Let's go to the pipelines. There's the run. There's the build. There's the tests. So where did it... Here's the tests. Summary, tests, and logs. The logs is not in here, but there. Hooray, there are no test failures. You see a summary of the test runs. All 5 passed. In Azure Devops, select test plans and select runs. Test plans, runs. There we are, completed. See the most recent test runs, including the one you just ran. Double click the most recent test run. Here we go. Nice. See a summary of the results. There's the TRX. This example, all 5 tests passed. If any failed, you could navigate to the build task to get additional details. You can also download the TRX file so you can examine it through VisStudio or another visualization tool. Although Mara and Andy added only 1 test is a good start. It fixes the immediate problem. Now the team has placed add more tests and run them to improve their process. Merge your branch into master. Mara and Andy are happy with the results, so they decide to merge the unit test branch to the master. In practice, that would be do the same, but for brevity, we'll skip that process for now. Add testing widget to your dashboard. Cool. Well, they're excited. The progress is made, and you need to add a widget to your dashboard to help visualize your test runs. Amita takes a look and is excited. That's a great progress. Things not sound ungrateful, but is there a way I can see a brief overview of my test results? Yes, Microsoft Azure Devops lets you add widgets to your dashboards. It only takes a few minutes as we show you. So in Azure DevOps, select Overview, select Dashboards. Overview, select Dashboards. It's empty right now. Select Edit. Add widget. Search for test results trend. Test results trend. And drag it on. Select the gear icon. Under Build Pipelines, select select your pipeline. This one. Keep the other default settings. Save, done editing. There's a little dot in there. Although the widget displays only 1 test run, you now have a way to visualize the test track, and here's examples show you few test runs. If you begin to see test failures, you can click on the point in the graph to navigate to that specific build. Nice, done editing. There's only 1 item that we can click. And that brings us to the full completed test. Perform code coverage testing. Much like the tool you use to unit testing, the tool used for code coverage depends on the programming language application framework you use. When you target .NET Core application to run Linux, Coverlet is a popular option. Not much to see here. Coverlet is a cross-platform code coverage library for .NET Core. Before we add code coverage to the pipeline, let's check with the team. Emitter feels much better, blah, blah, blah. Like the idea of unit testing. That one's code coverage. That's cool. Sounds like establish a baseline. That's right. Eventually, you can even configure that build to fail if we don't meet a given threshold. That would help us keep honest. That would help keep us honest. But for now, you can just see how much is covered. Great. Getting reports on how much code is covered by unit tests will help us identify the code paths that aren't covered. We can increase the code coverage gradually and help us save us from feeling overwhelmed by how much there is to do. I'm really excited about unit tests. I mostly do manual testing. I focus on the customer's perspective. I don't just look for bugs. I make sure the software does what it's specified to do, that the UI works, and that the user has a good experience. Blah, blah, blah. That perspective also is so important and definitely needs a human being. Right now, Andy and I are working on automated test software that tests the software. We're concentrating on tests that execute as the software moves through the pipeline. That means two types of tests we've already talked about. The unit tests test individual components and are really fast. Code coverage tells us how much of our code has associated unit tests. Lots of talking here. We should also think about doing lint testing for the command line, but before the build, lint testing can help us catch bugs, programming errors, and coding style issues. What about the regression test? I think of a regression test and unit test as almost the same thing. After we fix a bug, we should do a unit test again to ensure that changes haven't broken any units that were already tested. Okay, so that does that leave integration testing? Integration testing is a bit different. We do integration testing after the build on the server. Although unit tests help verify a single component like a functional method, integration testing verifies the multiple components work together. I don't think we're ready to integration test quite yet. But at some point, we also need to think about security and compliance. We should work with the security team to figure out how we can test again against their security policies. I remember that concern of Tim's, and I'd like to bring him in process more. Lots to do. Thanks for the rundown. I'm off. Keep me posted. Ready. Blah blah. Let's get started. A lot of reading in this section. The way you collect house code coverage done in .NET Core, the way you collect code coverage depends on what programming language. Yeah, that's what you already said. Mara, do some investigation around code coverage in .NET application. Here's what they find. Unit test project requires coverlet MS build NuGets package. A reference to this package already included Tailspin web test proj. Fish Studio on Windows provides a way to perform code coverage. However, because the team is building on Linux, they can use Coverlet, cross-platform code coverage library for .NET Core. Code coverage results are written in XML, so they can be processed by another tool. Azure Pipelines supports Cobertura and Giacoco. Code coverage utility for Java and Giacoco Java code coverage library. Mara and Andy decide to try Cobertura. to convert Cobertura coverage results to a format that's human readable, they can use a tool called Report Generator. Another one on GitHub. Supporting Open Cobertura, and Jacoco. Resulting in HTML Cobertura CSV packages. Okay. Let's run code coverage locally. Before Mara and Andy writes any pipeline code, they decide to try things manually to verify the process. Follow along with the process. Visual Studio Code, open the integrated terminal. It's already open. Here we are. .NET tool install, copy. This install the package. .NET tool install global. This is installing global. Okay, thanks for that. .NET report generator global tool. You can invoke the tool by using the following command: report generator. .NET report generator global tool was successfully installed. Cool. Run the following .NET test command to run your unit test and collect code coverage. Copy. Paste. So what's it doing? .NET test, no build, configuration release, collect coverage true, collect output format, Cobertura, collect coverlet output equals to test results coverage. Oh. Something's wrong here. That's probably because it's not in Bash. So let's go over to the terminal window then. We have a terminal somewhere. Windows terminal. There we are. Data projects build school 2. Oh. Change directory, I must learn. There. Let's configuration not recognized. Okay. Oh, I'm in DOS again. Thanks for that. Bash. Data project cd build. 2 cd there. Let's try again. Only one project can be specified. Okay. At line 2, character 5. Character 5, test. Missing expression after configuration. If the command fails, try running like this. Okay, copy. Escape. No. There it is. So what's the difference? Not found something. No. Unable to instrument module something because method not found. Void with a capital V. Okay. This command resembles the one that you ran previously. The P flags tells Coverlet which code coverage format to use when where to place the results. Run the following report generator command to convert cobertura file to HTML. Copy. Something happened. Writing the report file. Double click the index HTML to open it in the web browser. Try to find it in the Windows Explorer. Tests maybe, test results, coverage, code coverage index HTML. There it is. Okay, generated parser cobertura, no zero assemblies, zero line, no assemblies being covered. There's not much. And the reason is, I think, because of the error that's resulted earlier in here. So this failed actually. Scroll to the bottom of the page, code coverage by class. So we probably missed something here. Let's see if we can get bash in settings. Bash. Terminal. Explorer type. This one. Let's check on Google. Use bash in terminal VS Code. Use bash terminal VS Code. Open VS Studio. There you go. Install Git, that's already done. Open Studio Code and open the command palette. Ctrl Shift P, then open settings. Then select open user settings from the drop down menu. This step will open the default settings. Where's my code window? Ctrl Shift P. Oh, no, P. What do we need to find there? Open user setting. Open user settings. Yeah. Then use this tab to open up the default settings on the left. Which one? Oops, there we go. Oops. Open settings. Not much there. Now copy this line code to your Windows. Copy. Terminal integrated shell. Terminal integrated shell. Not Windows. There you are. Let's check if this is actually a right command. No. Let's see. Program files. Git. Git bash.exe. Bin. See program files. Git. Bin. Bash.exe. Yeah. That's right. Save. Let's check with this one. And save. Oops. The path of bash actually located. Shell with the system. If you are using Windows subsystem for Linux, Control tick to open terminal from Windows code. Yeah. So now you should get bash. Okay. Close this. Go to there. cmd code dot. Let's see. Close this. Close the setting. Let's keep it open. Control tick should bring up bash. We now have bash. Bring back this one. Copy. Let's check what's doing this. That's not running. Switch coverlet output format cobertura. It's unknown. Try the second one. See, there's lots of errors here, so it's not running this. Coverlet unable to instrument module E. Ghost method not found. Void system IO file stream in C's proj. Control click. Did we build it already? Clear. npm install. Something's happening. It went so smooth until this one. Unit test project requires the coverlet MS build project. References already included. The studio Windows provided a way to code coverage. Because the team is building Linux, they can use coverlet. Code coverage results written back to support cobertura. Convert called report generator. Report generator. Try to decide it manually. In the global install the report generator. That's done. Run the .NET test command. What's this? New minor version of npm available. Run in npm install global npm. Then npm install. npm audit fix. (291) low severity vulnerabilities. Nice. build. Let's go back to here. This is already done. So this is not running. Let's check the other one. Copy. Google. Trailing slash in the published dir property is escaping the end quote. Covenant output format. What if I do something like oops. Copy this and notepad. Let's try this. Don't wrap. Make sure there's no weird characters in there. this. Yep. One project. Trying to generate blah blah blah. We are collecting coverage to help resolve the issue. Attaching .NET tasks. Glad to hear it's working, but where's the solution then? Show comments. Here you are. Get the same results. Adding the below argument. So what did change then between this and that? Change coverlet output. Coverlet output format. This is not helping, guys. Copy. Must include couverture. Unable to pass property values containing semicolon. Something completely different. .NET Test. That's the approach. Collect coverage true, coverlet output covertura, coverlet output. That's the file name. It's in quotes. Is there a space in the name? That's maybe the issue. Spaces. No space in there. Where's my exercise here? Copy. Copy. Switch. Complaining about this one. Look, it shouldn't be hard to fix. Updated to the last version from Nugier. It cannot reproduce. Now let's check Nugier in there. That's the packages. Yeah, package JSON. I thought there should be the project was already included. Let's open this in Visual Studio. Don't save. Keep that open. That's the instruction. this in Fish Studio. Let's see what's added as the package. Project ready to use. Properties. No, I don't need properties. Updates. In Newton-John. Not Newton-John. Really? What did it say about this coverlet package? Unit test project requires coverlet build package. That's the build one. There it is. What if we update this? .NET Standard version 2. Unit. Let's try to get a version later. What? Yeah. Update. Let's try to build everything. Two succeeded. Let's quickly check what's going on if we do it on the prompt. Code dot. Control F. What was the name? Cover. Coverlet. There. Oops. So let's check it again with the updated things. Copy. Paste. No, that's not working. Copy. Yes. Okay. So this apparently worked. So now we have to get back to the instructions. This one was running. Run the report generator, copy. This looks better. Where is the test results in here? That's the Should be in here. This one. No. Opening browser. Let's do that with this. Code coverage. Index HTML. Look, that's a lot better. Finally. Okay. Let's continue with the exercise. Bring this to the side. So we need some little cheering here because it actually worked. Overtura parser. La 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 la. Do, 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 do. Not much coverage there. Select the link tailspin space web local document repository 1 for further details. To make it a little wider, which one? Local document DB repository. This one. Notice that the get item sync method is covered by unit test, but the count item sync has no coverage. Count item sync here. And that's completely red. Okay. This makes sense because the fetch only requested game region test calls the get items async method, but does not call the count item async method. Review the test code. See the document DB repository get item async shoot CS. I think it's this one. Create a branch. Okay. Clear. Git checkout B code coverage. Git checkout branch code coverage. Yeah. Add the build task. Modify Azure Pipeline. Copy Azure Pipeline. There. Ctrl A, Ctrl Del, Ctrl V. Save. That brings in the report generator and the unit test. Version builds upon the existing configuration. Cobertura. Push the branch to GitHub. Copy. Still giving the HTTP exception. What's the pipelines run? So quickly move to the pipelines. No, not this one. There you go. Pipelines. It's running. Add code coverage. Job is running. There we go. Run npm install. So we had to update the cover what's its name test. Cobertura. Project dependencies, release. Install report generator. That succeeded as well. Unit test succeeded. Nice. Finalized job. Finished. To published. Set up code coverage. What's Azure Pipelines run test? Here you see the test run. In Azure Pipelines, trace the build row through every step. That's what we did. When the build finishes, navigate back to the summary page and select Code Coverage tab. Code Coverage tab. Nice. As an optional step, you can explore the results from Azure Pipelines. Let's have a look at this. Still not using this one. Tests. Still running. Add a dashboard widget. In the previous part you added a test result trend. In this one you add a second one. In the new browser tab, go to Marketplace Visual Studio. On the Azure Devops tab, search code coverage. Azure Devops. Code coverage. Select code coverage widgets. There are so many. There's this one and there's this one. Equip. That's 44 and this is 8,000 times. So it should be this one, I think. Search code coverage, drag code coverage to the canvas. Get it free. Build and test for this one. All set. Proceed to organization. There we are again. Go to the dashboard. Overview dashboards. Edit. Code coverage. Drag code coverage. Select the gear icon. We select the width to 2. Build definition, select your pipeline. There you are. Coverage measurement enter lines. It's already lines. Okay. Select save. There we are. Widget shows the percentage of the code unit test cover. You now have code coverage set up via pipeline, although existing code coverage is low. Done editing. There's not much in there. Show the name of the build. Show the name of the build. There's more places to show. But this is the number. Okay, yeah, sure. Save. %. Okay. You now have code coverage set up. Later you can configure coverlet checks, see whether the test provides a minimum threshold. Threshold might be 30%, 50%, 80%, depending on your requirements. Remove code coverage. Recall that when you run a repo generator earlier, a number of HTML files appears in the code coverage folder. These HTML files are not intended to be included in source control, and you no longer need them, although the project gitignore already set them to ignore in the code coverage folder. It's a good idea to delete the files so that they not added to your Git repository in future modules. Investigate your code, go to the terminal window, and then in your project's root directory run command. Where's this one? What's the command? Remove rf code coverage dash. Remove dash rf code coverage slash. Okay, that's used in here. Let's try again. Still in use somewhere. There. Maybe. This one is using it. That's a duplicate. Still need this. Yeah. That's the learning. Try again. That was it. Next, unit exercise fixed failed test. At this point you have a way to run unit tests. As changes move through the build pipeline, you have a way to measure the amount of code. Blah, blah, blah. Get started code, push code to repository, watch the pipeline, quick chat. Where shows Andy updated build. Configuration of Azure Pipelines. Andy likes what he sees, especially the dashboard widgets. Last time we met, we got code coverage working on your laptop. It's great to see the same thing working on the build pipeline. Glad you got this working, blah, blah, blah. Be sure to add a unit test the next time I add a feature. It would be great to increase our code coverage. In fact, Amita is waiting for a new leaderboard feature so she can do unit testing on it. I promised her to have the change ready for today. See you later. Review the new unit test. And his latest feature involves a leaderboard. He needs to get a number of scores from the database, so he decided to write unit test verify the get item async method. Here's what the test looks like. You don't need to add it to the code just now. Test case 1 to 10. Expected result of 1, 0, 1, 10. Constant. Then there's tasks running. Something blah blah blah. Recall unit test provides inline data and unit calls return request count for 0, 1, and 10. Fetch the browse from GitHub. Visual Studio Code, open integrated terminal. Layer. It's a clean disk. Going to fetch the upstream for the failed test. We name the branch failed test, creates a branch there. And we're going to commit allow empty, trigger Azure Pipelines. This step is for learning purposes and is not typical. When you fork the repository from Microsoft account into yours, your fork already came with a failed test branch. Here you run the git commit command using the allow empty flag to create an additional entry in your commit history. So that's just for commenting. This command helps the next step successfully push to a change in GitHub. If you were to omit this step, the git push command that you run in the next step wouldn't take any action, therefore wouldn't cause the build to run. Now we push it, copy. That's the error again, without much impact. See the test failure. Now we should go to here, pipelines. Pipelines, last one, job, initialize job, there we are. Hopefully I keep some budget over on Azure to keep the end to get to the end of the month. Build a project. Installs the report generator. There was an error. There we are. Expected 10, but was 9. So let's go to the thingy. There you are. Test passes when 0 and fails at 1 or 10. The build is published to the pipeline only when the previous task succeeds. Here the build wasn't published because the unit test failed. In practice you won't always manually trace the build as it runs. Here are a few ways you might discover the failure. An email notification from Azure Devops. Azure Devops sends you an email notification when the build is complete. Subject line starts with build failed when the build fails. And in the test plans, in DevOps, go to test plans and then runs. This one failed. We open this. There you are. We have 2 failed. In Azure Devops, select this where you see the reason, including the ones that you just run. Select the latest completed test. You see that 2 out of 8 tests failed. Dashboards. Overview. Dashboards. We now see an issue there. 2 code coverage. No code coverage found. Because of the issues. The build batch and the readme. Where can we find the readme again? That should be on GitHub. Where's the GitHub thingy? Don't think I have it open again. GitHub. To my repositories. Last one. README. Build status is actually, it's down. So there is an error if it's failing. This one is missing. Although failed test branch doesn't include the batch. Oh, yeah. Here's what you would see on GitHub when the build fails. Because it's not in the branch. It's not in there. So that's indeed a different thing. Analyze the test failure. When the unit test fails, you ordinarily have 2 choices depending on the nature of the failure. If the test reveals a defect, you fix the code and rerun the test. If the functionality changes, adjust the test to match the new requirements. Mara noticed the build failure and checks in with Andy. Hey Andy, I saw the email notification in my inbox. Looks like the build is broken. Yes, I saw that as well. I already started to investigate. It looks like we have a failing unit test. Would you mind taking a look with me? Sure, let's have a look. Then Visual Studio Code open. In terminal run .NET build. Copy. Clear. Zero errors. Terminal run .NET test, copy. Test it, total 1 fail, there it goes. You see the same errors as you saw in the pipeline. 862. 862. Find the cause of the error. Mara notes that each failed test procedures a result that's off by 1. For example, when 10 is expected, 9 returns. One is expected, 0 returns. 10 expected, 9 returns. Look at the code for get item async. Where's get item async? Get item async. This one maybe. It's in the local document DB repository. Yeah, local documents. This one. This is the one. Result items as queryable where filter order descending skip page take page -1. So that must be page. Yeah, see. Examine the file on GitHub and notice it was recently changed. So timeline. There you go. Mara suspects the page size -1 is returning a few result and should be page size. Andy, do you remember why you made this change? I was experimenting with something and I must have forgotten to change it back. It looks like changing back to the original code will fix the issue. Mara decided to change the code back. Fix the issue. Copy this. Modify the thingy. Let's just close this. This one. Change that to this. Save. Save the file. Build it again. Zero errors. Now test it. Eight passed. Nice. The integrated terminal add each modified file to the index with the changes. Git status. Okay. Okay, dot in git add example wildcard. Return to Azure Pipelines. Is it building? The pipelines. Yes, it's building again. What was the message? Pipeline has pass rate of 66%, lower than 50% in the last 14 days. Okay. Pipeline insights. Interesting. Return correct number of items. Job. Still running. It's late again. Finished. Now let's have a look at the dashboard. And it's back. Code coverage 5.5. Not sure why it's now lower. So this is interesting. Why it's 17 then? Sounds like this is not right. Kind of strange that the board not showing the code coverage overview dashboard. Refresh. Something's off. Not sure why it's only 5.5% now. Must be a reason for that. Not showing the code coverage here. Hey David, how are you doing? I'm doing something completely different these days. Doing the code skill challenge. Like a bank project. Trying to do 28 modules that part of the build challenge. From the build conference they have a challenge to do 28 modules. You go to the leaderboard. It opens on the other screen. Obviously I'm in the stream with the lowest numbers and the lowest rank, sadly. No way that we win it because this needs to be captured before June the 2nd, I think, the last day. So that's a little bit different. And I'm now at, let me check again, module 3 for Azure Devops. This one, run the quality tests. Almost ready, 98%. So what you're doing these days? Let me see the instructions back again here. We fixed the build. That was right. Exercise, clean up the DevOps environment. Yeah, that's a finishing part. Clean up, move the work to done. So we need to go to the overview, the boards. We finished check for vulnerabilities. Oh no, that's the next one. Create unit test, this one. Completed it. I'm always for the underdog, putting together a PC. Oh really? Like a streaming PC or something else? Maybe? I think it's always fun to build your own PC. This streaming PC that I have over here, I built myself with the at the time the best components available. And nowadays it's I think it's already 3 years old, 2 years old, 2-3 years maybe. But it's still compared to what is in stores, it's still a strong PC. But I think there's a GTX in there, and I would like to upgrade it to an RTX graphics card. But it might be better to then upgrade it completely. Disable the pipeline or delete the project. Let's just delete the project because you get a new one in the next step. Go to this one, enter. This is fun. The delete option is at the cog behind the name, but it's only available when you're hovering over. I wonder if that's related to the dark setting. It's pipelines, general. Not sure where the dark setting is. Oh, that's interesting because this one is the same thing as the one that you get behind your name. I'm looking like crazy for this one, but it's probably the same as this one. See, because here's the delete project and take the name for the project. All the work that we put in for the last 2 hours, I'm now going to delete. There we go, cleaning up, otherwise it will take too much costs in the system. Now it's gone. Complete the challenge. Continue. Summary. So a lot of blah blah with exploring what we did here. Learn more. Unit code. So we fixed another thing again that was incorrect in the documentation. So I mainly want to more bang for my buck. VMs deploy, development, new thread rate per CPU. Yeah, I might need an update myself, but I probably will go for new screens and a new camera first. Especially the camera is quite expensive. Unlock achievement. Let's do it. There you are. Tra-la-la-la-la. Make a screenshot. So we can put it on Twitter lately after the show. Copy. Continue to the next module. Well, we're not going to do the next module today, sadly enough. So let's do some administration in here. We finished this one. Let's refresh this. Should now be at 100%. Yes. And let's see. This one can close. Also, the project is gone. And we have to update this one. Second tab. We have now finished the third one. We get a check over there. And we move now to 16. 57% finished. And need to do 12 more. And that's a lot for Friday, Saturday and Sunday. 3 days, 12. That's four to do each day. And this one, if you looked at this one, it should take 1 hour and 22 minutes. And if I go to my timer clock, Where's my clock? There's the clock. We've been taking 2 hours and 11 minutes for this single module. It's almost an hour overtime just by messing with the unit test tooling that was not up to date. Oh, I did not even put a comment in there. I should have put some comments in there that it's actually failing by default. I'm not sure if it's still possible to do that. No, that's sad. I actually wanted to provide some feedback that the build is failing from this information here. Let's see. It's adding the widgets. This one is failing. Next one. Well, anyway, the default text is failing. Is it team or individual? Well, actually, it's both. The interesting part is that if you go to the leaderboard, this link, put this in the chat. That's this link. You get appointed into one of 5 teams, and there are a lot of people in the teams because every one of these numbers stands for a complete collection. For instance, if you have the collection that I started with, the languages and frameworks, if you go to that one, you notice that there are 1, 2, 3, 4, 5, 6, 7, 8 modules in, all about 1 hour. So that's 6 hours and 3 minutes, according to the measurements on the modules itself. But in real time, it's a little bit longer because some things are failing. And so if you complete one of these modules, that's equivalent for the one item in the leaderboard. Oh, wow. The leaderboard is failing. So this is 17, like 3,000, 6,000, let's say 8,000 collections completed. So that's a lot of hours for everyone. But there's some calculation in it. If you're in the winning team, you get your points are tripled, and if you're second, then your points are duplicated, and you get certain points for every collection that you did, and that will go into a raffle. Here you see that the winner gets, oh, it's even worse. The winner gets 10 times, second one 3 times, and the rest single time. But you get in the raffle, and these are the prizes. But even if you don't win, if you complete one of the collections, so one of these collections, then you get a free voucher to do a certification test. Some free Microsoft certification exam. And then you can pick one of the big list. That's a huge list of exams that you can do. Official rules. Prizes. Yeah, so the most prizes will probably fall in the first team, but I don't really care as long as I get at least a free certification option. So I can try one of the tests, see if I can get a certificate for that. But I actually think it's fun to do, and it's really a challenge. So also thought it would be fun to do it on live stream. So tomorrow probably we'll be doing the last one from the Devops session, and that should take almost 2 hours. That's crazy. Even if there is some difficulties in there, it might extend to 2.5 hours maybe. But we'll see. So that will be my complete Friday, and then I have even 11 left, I think, from the other areas, like the serverless areas. But these are a little bit smaller, way under an hour, but this one over an hour, it's over an hour. This one 20 minutes, that's not much at all. But in general, this is 5 hours. And the teams, that's a big one, I think. 6 hours, so that's 11 hours for Saturday and Sunday. Yeah, never stop learning. And I already decided that I'm going to do the Azure 203, I think 203 exam after this. Because I already did the training for this, and but if you look at all these items, it's even worse. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9 collections. And if you go, for instance, in the first collection, that's already 8 hours. So that's about a full work week. But I can do this on stream as well. And the interesting part is that some of the items are already part of the for the challenge. So I can use the free voucher to do the test for this. So that's also fun. Hopefully it will give me the certificate, and otherwise I can just do it again. You never know. Keep learning. And let's wrap up for today. Because from my time it's 1:34 a.m. in the morning. And I need to go to bed and get up early in the morning at 7 a.m. again. Live stuff, but that's how it goes. Let's move into the main window. So good to see everyone again. Thanks for watching. If you like to follow my stream or subscribe if you are watching on YouTube, just do so you know when my next stream is. David, I know, is already following, so it was good to see you again, and hope to see you next time again. And thanks for watching, and see you the following time. Bye bye.